Hello everyone, in this video I'm going to discuss the situation for special probability distribution. A biased dice is thrown 200 times, so here we have the n. If the probabilities of obtaining the digit 1 is 0.35, so here we have the probability of success of getting 1. So means that at the beginning we have the title binomial distributed 200 and then we have 0.35 of getting 1. Find the probabilities that obtaining the digit 1 on the dice exactly 75 times. So as we all know, from here we have the situation which is n is greater than 0.5. So here we have the situation n which is greater than 50. Next, we have to test whether the Poisson distribution is suitable or not. So in order to find the lambda, we need to have 200 multiplied with 0.35. So we will have 70. So do remember the condition. Number 1, n must be greater than 50. Number 2, p must be less than 0.1. So in here, p is greater than 0.1. So means that Poisson distribution is not suitable. Continue. In order to have the normal, so where we have the mean, which is the 70. Next is to find the standard deviation squared, where we have to multiply 70 multiplied with 0.65. So we will have 45.5, we have the square root and also the square, where we express the situation as mu and the standard deviation squared. So meaning that in here, we have moved from the discrete towards the normal, which is the continuous. So do remember continuity correction. So for the A, where we have x is equals to 75. So step number 1, continuity correction, we have the dense circle. Remember, if we have dense, we need to create the empty. So we have the probability x is greater than 75 minus with 0.5. So we have 74.5. Less than, we have 75 plus with 0.5. So we have 7.5.5. Step number 1, continuity correction. Step number 2, standardize. So where we have 74.5 minus 70 over square root of 45.5. Z, standardized, 75.5 minus 70 over square root of 45.5. Simplify the situation. So where we have Z is greater than 0.67 less than 0.82. But refers to the graph, so where we have 0.67, 0.82 shaded the region. So create the formula. So probabilities that Z greater than 0.67 minus probabilities that Z greater than 0.82. But refers to the table. So number 1 we have 0.67. So here we have 0.2514. Next, 0.82, where we have 0.2061. So probabilities that Z greater than 0.67, we have 0.2514 minus probabilities that Z greater than 0.82, where we have 0.2061. So the probabilities that X is equals to 75, which is equals to 0.0453. Next, we have B. Find the probabilities that X is in between 65 and 85 times. So where we have 65, 85. Number 1, continuity correction. Refers to the number line where we have 65 and 85. Empty circle. Next, continuity correction. When we have empty, means that we need a dense. So, after the correction, where we have x is greater equals to 65 plus with the 0.5. So we have 65.5. Next, we have 85 minus with the 0.5. So 84.5. Step number 1, continuity correction. Step number 2, standardize. Where we have 65.5 minus with the 70 over square root of 45.5. Z, 84.5 minus 70 over square root of 45.5. So simplify the situation. So where we have Z is greater equals to negative 0.67 less than equals to 2.15. Kindly refers to the diagram. We have negative 0.67, we have 2.15. Shaded the region, create the formula, meaning that we have to eliminate this part and also the left hand side. So where we have 1 minus probability that z greater than 2.15 minus probability that z greater than 0.67. By refers to the table, first refers to 0.67, where we have 0.2514. Next refers to 2.15. So here we have 2.1 and then 0.05, so we will have 0.0158 for 2.15 as a z. So here we have 1 minus z greater than 2.15. So here we have 0.0158 minus z greater than 0.67, 0.2514. So the probability is that x is greater than 65 and less than 85 will be equals to 0.7327.